final two examples involving inverse trig. For starters, we have the limit here, okay, and we're starting to train ourselves to see this limit and understand what's actually being asked here. We're not actually looking for you to do a limit out here. It's going to take too much time and effort. Okay, what is this limit really asking us to do? The limit as h approaches 0, we're seeing that, and the derivative is coming into mind here. So we're looking for the derivative of f of x. Well, what is f of x? Okay, well, this whole expression right here is basically telling us that f of x is equal to the term after the minus sign. Don't include the minus sign, everything in the numerator after the minus sign. So f of x is equal to the inverse tangent of 2x squared, and we're interested in the derivative of that function. Okay, so this is the same type of problem as the previous two examples. It's just presented in an alternate manner, and the question is, do you as the solver understand what's being asked of you? Oh, all we're looking for is the derivative of inverse tangent of 2x squared. Okay, we can do that. Let's go ahead. Chain rule again, because we have inverse tangent not of x, but of 2x squared. We have an inner function. We need to use the chain rule. Well, our inverse tangent derivative is right here. Let's go ahead and use that template because we're going to derive the outer function. When we derive the outer function, we have 1 over 1 plus. Okay, but it's not going to be x squared. It's going to be the inner function squared. We keep the inner function. So we're going to have 2x squared being squared. And then we multiply that by the derivative of the inner function. All right, and the derivative is going to be 4x. All right, so multiplied by 4x right there. That's the derivative of 2x squared. And we can simplify this ever so slightly. We have 4x moving up into the numerator. And then down here we have 2x squared being squared, so that's going to be 4x to the fourth. So 4x divided by the quantity 1 plus 4x to the fourth, that's our answer for example 41. For example 42, we have inverse cosine of x. We're asked to derive this and then plug radical 3 over 2 into the answer. Let's see what happens. We already know what the derivative is going to be. It's up here on the board. All right, we're working to memorize that. So we've got negative 1 over square root 1 minus x squared. But we're interested in the value when x is equal to radical 3 over 2. So we're going to have negative 1 over square root 1 minus radical 3 over 2 squared. And just leaving your answer like that is not going to be good enough because it's going to be a multiple choice question if it does come up. And the answer is going to be a simplified version of that. So let's simplify this. We have the square root of 3 over 2 being squared. That means we square the numerator and we square the denominator. That's how we can work when we have exponents and fractions. So that gives us negative 1 still in the numerator, and then square root 1 minus radical 3 being squared. The square and the square root, they wipe each other out, and we're left with just 3. In the denominator, we have 2 being squared. 2 squared? 4. So we have 1 minus 3/4 underneath the radical. What's 1 minus 3/4? Yeah, 1/4. So this is equal to negative 1 over the square root of 1/4. Right? What's the square root of a fourth? What fraction times itself is 1 over 4? Well, the square root of 1/4 is the same thing as the square root of 1 over the square root of 4. Square root of 1 is 1. Square root of 4 is 2. So this is equal to negative 1 over a half. And how many times does a half go into negative 1? Goes in negative 2 times. So all that work for a negative 2.